In this lesson, you will identify linear, quadratic, and exponential functions just from the data, and we'll also write equations from data. So the first thing that you'll do is try to identify just from a graph if something is linear, quadratic, or exponential. So let's just review. A linear graph, remember, is going to be a line. So it doesn't matter if it's going up, down, it's a line. A quadratic graph, if you'll remember, is going to be a parabola. And that parabola, it doesn't matter if it's going up, if it's going down, if it's touching an axis or not. As long as it's a U-shape, it's quadratic. An exponential graph, if you'll remember, is going to be a curve, where it's going to approach either the axis or it's going to approach one of the y values. So exponential, it can be a curve going left, it could be a curve going right, but it's definitely going to be a curve. So graphically, those are the differences between the three. We'll talk about the equations in a little bit. So for example 1, you're just going to graph, and then looking at the graph, tell me if it's linear, quadratic, or exponential. So let's just start, -2, 5. Now I'm not saying you're going to have to graph the entire thing. I mean, you can maybe figure it out after you have a little bit graph, but I think it's a good idea to practice our graphing skills. So I'm at 0, 1, here's 1, 2, and here you should be able to see what's going on, and 2, 5. So we know for sure then that this is a U shape, so then we would call this quadratic. Okay, so then we start then with the next graph, which is -2, 1/4, -1, 1/2, 0, 1, 1, 2, and by here you should see what's going on, 2, 4. So this is your curve. So then we know that that graph is exponential. So I'm going to give you a grid in your notes, and what I'd like you to do is to look at your coordinates and see if you can identify which type of graph it is. So try that now. All right, the next thing that you'll do is look at a set of data, and now we don't want to graph, we just want to look at the points. And so what we're going to do is subtract. And if we subtract once and we get a common difference by subtracting once, then we call it linear. If we subtract it twice and then get a common difference, and I'll show you what I mean by that, then we call it quadratic. And if we cannot do anything by subtraction, then we will call it exponential, because then it should have a common ratio. So we start by subtracting. So -8 minus -3, that's going to be -5. -3 minus 2 is -5. That's 5. Actually, that'd be plus and plus. Sorry about that. And plus. So this has a common difference of 5, so we would say that this is linear. We're going up 5 here, up 5 here. So sorry if I confused anybody with the negatives there. Up 5, up 5, up 5, up 5. Okay, so over here, if you'll notice, we're going down by 4, down by 2, down by 1, down by 1/2. Well, if I try subtracting again, these have a difference of 2, these have a difference of 1. This is not going to be twice. So then I look for a common ratio. That's a divide by 2, divide by 2, divide by 2, divide by 2. So this has a common ratio of 1/2. So then we would say that that is exponential, because exponential has a common ratio. Looking at this set of data, we subtract. That's going down 4. This is down 2. This is 0. And this is up 2. Those definitely are not the same, so then we subtract again. That's going up 2, up 2, up 2. So since we subtracted twice and we get a commonality, then that's what we call quadratic. So you've seen an example of all three. Subtracting once and getting a common is linear. Subtracting twice and getting a common is quadratic. And then a ratio instead of subtraction is exponential. So you try the example in your notes now. Now, which kind of model best describes this data? And then we have to write an equation for it. So these are our 3 equations we're going to use. Y equals ax squared. A is going to be that value. We're going to use maybe a little bit of substitution. Exponential is y equals ab to the x. And we'll use some substitution. A common ratio is always your b. And linear, y equals mx plus b. M is going to be your slope, and b is going to be your y-intercept. So this is going to be your common difference. And we'll talk about the equations a little bit. Let's first of all figure out what type of graph this would be. Well, I use subtraction, and if you notice, this is going up by 2, this is up by 6, and up by 10. So if I do some common subtracting here, I have that difference of 4, difference of 4. So since I'm going twice and getting that commonality, then this is what we call quadratic. So when I look at a quadratic, I've got to figure out, if you look at this equation here, what we know in a quadratic equation is that I'm going to have y equals, and I know I'm going to have my x to the power of 2. So what you're going to do is you're going to substitute some values here. Y, I can choose any y. X, I can choose any x. So we're going to do, let's not do 0, 0, because that wouldn't help us out at all. But let's maybe do like the negative 1, 2. So I'm going to say when 2 is y, that is equal to some value, and we're going to have a value of, this is quadratic, so some value of a, so I'm going to call that a, times this value x, which is negative 1, squared. So then we just do a little bit of algebra here. So 2 is equal to negative 1 to the power of 2 is positive 1, so that's just a. So a is equal to 2. So this would be y equals, I'm going to substitute that a value in, 2, and then x squared. Now you can graph this if you'd like to see if it fits these coordinates, but that is how you will find. You'll substitute a y value in, an x value in, and then solve to find what your a value is. Let's try another example here. So here we have a new set of values. I still have my equations up here to help us out. If you can see that this is going up by 4, this is going up by 4, that's 4, that's 4. So we're going to say that this is linear. And when I have a linear equation, I could plug in a y and plug in an x, but don't we already know enough about linear equations that we know that this is our y-intercept? So we know our b is 3. Don't we already know that? And don't we know that our common difference is 4? So don't we already know that our m is 4? So I don't think you have to do substitution on a linear. I think you can use your points to help you. And this would be y equals 4x plus 3. Now if you want to use some substitution like you did with a quadratic, I'm okay with that, but that's how you would find a linear equation from a set of values. Let's try one more, and then I'll give you one in your notes to try. Obviously, this is going to be exponential, because we haven't done one of those yet. So just to prove that it's exponential, can you see how this is a divide by 2, divide by 2, divide by 2, divide by 2? So I have a common ratio of a half, because everything is half as we're going up here. So this is definitely exponential. Now, in an exponential, my common ratio is going to be my b value. So I have 1/2 to the x, because I have b to the x, and I have some value a that's going to be out front. And what I have to do is try to figure out what that a is. So what we're going to do is we're going to do a little bit of substitution to kind of help us out here. So as you can see in exponential, what we have, stop, I can't do it.